This video presentation is the first one is introduction, type of gravimetric analysis, background, experiment demonstration, application, and conclusion. This video presentation is the first one.
Gravimetric analysis is an analytical technique that determines the quantity of a specific substance by measuring its mass. The method involves converting the substance into a pure solid form through chemical reactions, followed by precise weighing. This approach is widely appreciated for its accuracy and straightforward execution.
Next, we move to the type of gravimetric analysis. The first one is precipitation method. Precipitation gravimetry is a method used to measure the amount of substance in a solution by forming a solid. A substance called a precipitant is added to the solution to make a solid form. Then, the solid is separated from the liquid using filtration. After weighing the solid, balanced chemical equation can be used to calculate how much of the substance was in the original solution. The second one is thermogravimetry. This method used to observe change in the sample's physical and chemical characteristics over time at different temperature or to calculate the sample mass. The third one is volatilization method. In volatilization gravimetry, the component of the mixture are separated by heating or chemically break down the sample. Any volatile compound are separated out by heating or chemical decomposition, which causes a change in mass that can be measured. The last one is electrogravimetry. Electrogravimetry works on a similar concept as electroplating, in which the metal ions are separated from the solution by depositing on the electrode surface.
Calcium is essential for strong bones, teeth, and overall health. Milk powder is a popular source of calcium, so accurately measuring its calcium content is important for nutrition levels and quality control. Gravimetric analysis is a simple and reliable method often used for this purpose. This study uses gravimetric analysis to measure calcium in milk powder by isolating it as a solid compound, which is then weighed to determine the calcium content. The method is accurate, cost-effective, and commonly used in food testing. The principle behind this study is precipitation reaction, thermal decomposition, and mass-to-composition conversion.
Next, we move to the methodology. The purpose of this methodology is to determine the content percent of calcium in milk powder through gravimetric analysis.
The materials used in this study is ammonium oxalate, distilled water, milk powder sample, dilute hydrochloric acid, and the apparatus is filter paper, funnel, beaker, and analytical balance.
The first step for this methodology is dissolve a known mass of milk powder, for example 5 grams of milk powder in distilled water to extract the calcium ions. Next, add the excess ammonium oxalate solution to form calcium oxalate precipitate. Heat gently to ensure complete precipitation. The third step of the experiment is filter the calcium oxalate precipitate using filter paper. Wash the precipitate with distilled water to remove impurities. Dry the precipitate in an oven to a constant mass. The fourth step is use an analytical balance to determine the mass of the dried calcium oxalate. The last step of the experiment is calculate the calcium content in the milk powder based on the mass of calcium oxalate obtained. We can use the formula percentage analyte in sample equal to weight analyte over weight sample times 100%. Next, we move to the data analysis. In the data analysis, we will discuss about the percentage of calcium content in milk powder. There are 4 steps to find the percentage, which is the first one is we need to find the mole of calcium oxalate. Next, find the mole of calcium. The third one is we need to find the mass of calcium, and finally we can calculate the percentage of calcium in milk powder. There are example result data for this data analysis, which is mass of milk powder used is 5 gram and mass of calcium oxalate obtained is 0.5 gram. Next, we move to the calculation of the data analysis. Firstly, after we calculate the mole of calcium oxalate using formula mass of calcium oxalate divided by molar mass of calcium oxalate, and we found that 3.42 times 10 to the power of negative 3 is the mole of calcium oxalate. Next, mole of calcium, when we refer to the chemical equation, which is 1 mole of calcium react with 1 mole oxalate produce calcium oxalate. So this proves that the mole of calcium is equal to the mole of calcium oxalate. Next, mass of calcium, we can find the mass of calcium by using the formula mole of calcium times molar mass of calcium, and the mass obtained is 0.137 gram. And the last one is percentage of calcium content. We can use formula mass of calcium divided by mass of milk powder sample, which is 0.137 gram divided by 5 gram times 100%, and the result we obtain is 2.74%.
Now, gravimetric analysis can be used in these 4 real-life applications: environmental studies, metallurgy, food science, and pharmaceuticals. Let me explain how. For environmental studies, gravimetric analysis is used to monitor water quality. For instance, scientists measure the levels of harmful substances like sulfate or phosphate in water to ensure it's safe for drinking or aquatic life. For metallurgy, gravimetric analysis is used to analyze the composition of metals and impurities in raw materials like ores. This helps manufacturers maintain the quality of their final products. For food science, it's used to determine the calcium content in milk powder or to measure ash content in food products, which helps ensure nutritional quality and compliance with standards. And lastly, for pharmaceuticals, gravimetric analysis is used to make sure drugs are formulated correctly by measuring the precise amount of active ingredients. It ensures the medicine is effective and safe to use.
In conclusion, gravimetric analysis is a relevant way to measure calcium in milk powder. It provides accurate results when the process is carefully followed, including proper sample preparation and drying. This method help ensure that milk powder meet nutritional and quality standard, benefiting both consumer and manufacturer.